Hey, hi everyone. In this video, we will see what is scatter plot and when it can be used. We have already created a video on how to create a scatter plot using matplotlib package. You can watch it if you want to plot scatter plot using matplotlib package. But in this video, we will see how to plot scatter plot using Seaborn package in Python. Now, what is scatter plot? A scatter plot can be used to visualize a relationship between variables. A scatter plot is used in univariate analysis, bivariate analysis, and multivariate analysis also, depending on number of variables you are going to consider. If you want to analyze a single variable, then you can go for univariate analysis. If you want to find the relation between two variables, you can go for bivariate analysis. And if you want to find the relation between three or more than three variables, you can go for multivariate analysis. And this all kind of analysis can be done using scatter plot. Scatter plot is very versatile and informative data visualization technique that can help to get a deep understanding of a data, identify patterns, correlations, outliers, and it can be used to make the data driven decisions. Now I will tell you the 10 benefits of scatter plot that it offers. The first benefit of scatter plot is we can visualize the relationship between different variables. So if you want to see the distribution of a single variable, then you can go for univariate analysis. If you want to see the relationship between two variables, then we can go for bivariate analysis using scatter plot. And if you want to go to check the relationship between three or more than three variables, you can go for a multivariate scatter plot. Second benefit scatter plot offer is if we can use scatter plot to identify the trends. So either the trend is positive or it is negative, or if it is not having any trend. So this kind of trends identification can be done using scatter plot. Third benefit scatter plot gives that it can be used to detect outliers. And what is outlier? Outlier is any point which is very far from the remaining points. That point can be called as outliers points. And using scatter plot, we can identify the outliers also. Fourth benefit is comparing data. So we can compare data using scatter plot. So if we have different variables, we can plot all those variables and we can observe the difference between them by visualizing the scatter plots. Fifth benefit scatter plot offer is that it can visualize the multivariate data, and that is a very important benefit. If we want to plot the graph which contains more than two variables, so maybe three, maybe four, then we can definitely use scatter plot to go for visualizing the multivariate data. Sixth benefit scatter plot offers is that scatter plot can be used to check the correlations in the data. So definitely the correlations, we can find it out using scatter plot. Seventh benefit is that scatter plot is going to help us to do the EDA, that is exploratory data analysis. And exploratory data analysis is going to give understanding of a data, what are the patterns available in the data, what is the insights present in the data. So all this basically is going to give by this particular EDA. Eighth benefit scatter plot gives is that it's basically useful for communications. What is communications? Now, for example, if you want to communicate some insights present in the data, you can plot the scatter plot for that data. And after plotting, you can easily understand the data and you can communicate those results with your other team members and so on. Ninth benefit scatter plot offer is that it can be used for decision making. Once we are going to plot a data, definitely we can go for decision making also. And at the end, we can go for data cleaning also. So this is the 10th benefit of scatter plot, that is data cleaning. Now you might be thinking that how scatter plot can be used for data cleaning. The answer is definitely yes, because if you are going to plot a scatter plot, then we will get to know where the outliers are present, if outliers are there, and we can remove the outliers. And if you are going to remove the outliers, that is the process of data cleaning also. So scatter plot can be used for data cleaning. Now let us see what are the types of relations present in the features. So let me zoom this particular image and let me scroll a little bit left. Okay, So if you see here, if data is presented in this format, the first, so this is basically perfect positive correlation. This is basically x-axis and this is y-axis. If x increases, y also increases, and there is no any outliers. All the points are lying on the specific trend line. So we can say that, so lines we are not going to plot in the scatter plot, but these all points are present in the same straight line, in the same straight line. So that is basically positive correlation, and we can say that this is the perfect positive correlation. If few of the points are appearing on the trend line and few points are little bit outside, but still if x increases, y also increases. If x decreases, y also decreases. And if this is the pattern, then we can say that this is also positive correlation, but it's a highly positive correlation, and this is perfect positive correlation because all the points are on the same trend line. If you see this particular image, third image, so if you see the value r is basically a relation that is 1. It's a perfectly positive correlation. R equal to 0.8, it's a positive, highly positive correlation. If r equal to 0.3, yeah, if x increases, y also increases. If x decreases, y also decreases. But there are some points which are far from the this trend line, and these all points are not lying on the specific trend line. This is positive correlation, but it's a low positive correlation. If your data distribution is like this, x increases, we are not sure about what is going to happen with y. Y may increase or y may decrease. If x decreases, we are again not sure about what will be the case of y. Y will increase or y will decrease. So if this is such kind of relation is there, distribution is there for that particular variable, then we can say that there is no correlation. Similarly, now the vice versa of this all three. So this is low positive correlation. If you have a trend like this, if x increases, y decreases, then this is low negative correlation because the points are very far from each other. This is highly negative correlation. X increases, y decreases, and the points are nearer to the trend line. Even if you are going to see this last image, though r equal to -1. So if you observe here the value of r, -0.3, -0.8, -1 indicates negative correlation, and the plus value indicates positive correlation. These all points are present in the same line, so it's a perfect negative correlation, and so on. Now let us discuss how scatter plot can be used for all types of analysis. All types of analysis means it can be used for univariate analysis, it can be used for bivariate analysis, it can be used for multivariate analysis also. So let us discuss in short, right? So this is the way using which what we can do. We can plot a scatter plot for univariate data. So if we want to see the distribution of a single variable, then we can go for univariate scatter plot, where on x-axis we can take that particular variable, and on y-axis we can keep a specific constant. So univariate scatter plot contains only one variable, and it can be used to visualize the distribution of single variables data point. X-axis basically is going to represent the value of variable, and the y-axis typically contains the constant value. If you see here, all y is basically constant, 0 value we have set here. And from this particular graph, right, we don't have any other variable, we have only one MPG variable, mileage per gallon variable, and we can see the distribution of this particular variable. So this is the scatter plot for only single variable. That's why this is univariate scatter plot. Then we can go for bivariate scatter plot. In bivariate scatter plot, we can have multiple, we can have basically two variables. So on x-axis we have taken horsepower, and y-axis we have taken acceleration, and we have plotted the relation, these all data points in between them. And now if you are going to find the relation between this, you can see this is not increasing relation, it's a decreasing relation. So it's not a positive relation, it's a negative specific relation. And to be a specific, it's a low negative correlation, because it's not a perfect negative correlation, because not all the points are on the same line. Even this trend line, the points are far from the trend line, not near to the trend line. So this image looks like this. So the relation between this horsepower and acceleration is basically a negative. So then it will be a low negative correlation. Now let us discuss how scatter plot can be used for multivariate analysis. So normally when we are going to plot the graphs, we can plot two things, x-axis and y-axis. Even I will show you in another video how basically we can go for 3D plotting, 3D scatter plot, or 3D plots for different more than two variables. So that I will show in another variable. But right now, when we are going to plotting this horsepower versus acceleration, then we will have only, this is the two dimensional. But if you want to include one more dimension into this particular graph, then that is going to become multivariate scatter plot. And here one more dimension that we are going to add here is origin. So origin, we have basically three values, USA, Japan and Europe. And we have done the color coding. USA is indicated as a blue, Japan is indicated as a orange, and Europe is indicated as a green. So this in this particular image, right? So we have three dimensions now: horsepower, acceleration, and origin. So we can plot a multivariate scatter plot like this. So here for third dimensions, right, we have used color coding, but only color coding option is not always flexible. Sometimes we can use another options also. Like for example, if you see here, here I have specified the size option as a third variable dimensions. The first dimension will be same horsepower, second dimension will be same acceleration, and third dimension instead of color we can go for size, and we can set the size for each specific element. So for USA, very small circle is there, Japan middle size circle is there, and Europe little bit big is there. So for example, these circles are basically USA data points, these big circles are basically Europe data points, and if you see this circle, right, this is basically Japan, this is also Japan circle, and so on. So third dimensions we can add into the graph, right, by either by color coding, or we can go for size also. Even if you want to mix this color coding plus size also, then this is also possible. You can see, let me scroll it little bit right side. So horsepower will be the x-axis, acceleration will be y-axis, and the third axis which we are going to add as origin. Even if what we have done is here we have used size also along with color coding also. So this is the another way using which we can go for multivariate analysis using scatter plot. Even only by using color or only by using size, instead of this we can have one more option, that is basically change the symbol itself. So we can choose the different symbol for different categories. So for USA we have used circle here, for Japan we have used here star, and Europe we have used square. So these are basically circles. This is basically USA. Here you can see some few stars, so that is basically Japan, and wherever you can see the square, that these are basically data points from the Europe category from the origin. So in this way we can go for adding the third dimensions to the particular multivariate scatter plot. And now if you are going to see, here we have used different symbols, but again we can change the color of those symbols also. So here you can see the blue color is given for USA, and basically these are represented by circles. Japan is having orange color and they are having basically star, you can see the star points, and Europe is having a square but it is having a rectangle, basically square symbol. So we have used these two basically options here. We have used different symbols also and colors also together. So these are different ways using which we can go for multivariate data analysis using scatter plot. So let us go to computer and see now how we can implement these kind of different graphs for real-time examples. So let me close this now and let me just open this particular notebook. Anyhow, I will keep this notebook available for you guys on my GitHub repo. So you can find this image and this notebook from there. So first of all, we will import the libraries. So Seaborn we have imported as SNS, and matplotlib.pyplot we have imported as PLT. Then if you have data set available in local file system, right, in CSV file or Excel file, you can read the local data set using pandas module. But right now I'm going to take a built-in data set which is available inside Seaborn using this particular property, this particular method, load data set, and this data set name is basically MPG. MPG stands for miles per gallon. It's a basically automobile data set, and that is stored into DF. So if I'm going to run this, you can see we have mileage per gallon variable, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and name. Name is a text column. Origin is basically categorical column in which we have USA, Japan, and Europe values, and these all others are numerical values, numerical basically features or variables. Now if you want to plot univariate scatter plot, we can choose any of the numerical value basically. For example, let's take an MPG. We'll do the analysis. We will check the data distribution of MPG using univariate scatter plot. So how we can do this? So we can use scatter plot method available in Seaborn, and we can pass basically, this is the figure which we have created. The size of figure is 8:3, and here we need to pass two things, X and Y, but we need to find out, we have to go for univariate analysis, and for univariate analysis we can go for only one axis, right? So we want to check the distribution of MPG. So MPG will be my X axis. In that case, what will be Y? That is the question. So Y we can create using this way. So what we can do, we can create a Y which will have some constant value. So let me show you. If I'm going to check the length of this particular, let me close the bracket and let me run this. So we have 398 values present here. These will be X values. The corresponding Y, I want to create 398 zeros, right? So we can multiply with 0, and if we are going to, let me delete this, right, and let me run this. So this is the one more variable which we are creating as a constant Y, which contain, let me print this. So if you see, so this 0 0 0 0 0 0, so 398 zeros, right, will be present in this constant Y, and this value we can use as a Y. So if you see here, the X-axis is given as a MPG, mileage per gallon, and Y-axis is given as constant value, and the label is basically MPG. And if you are going to give X label MPG, this MPG will come. Title is basically this. Grid will be shown using grid. This background square boxes basically, and this is basically is used to show the graph. If we are going to run this, the distribution will be like this. So if you see now, the mileage per gallon, right, more data points are overlapping from here to here, right? So it's around 14 to it's around 38. So by observing this chart, we can see that more data points are overlapping on each other between the value of MPG is 14 to 38, and these are little bit less spreaded, and these are also little bit less spreaded. So people are not preferring this univariate scatter plot for analyzing single variable. Instead of this, you can prefer histogram also, because here more number of data points are overlapping on each other. That's why it is not visible properly. So if you create a bins of a specific range, then you can plot a histogram, and you can prefer histogram to see the data distribution of a single variable. But scatter plot can also be used to see the data distribution of single variable, right? Now let us go for bivariate. In case of bivariate, let us choose two columns, two features basically. We'll check the horsepower and acceleration. So horsepower will have 398 values, and acceleration we will have the 398 values. And let us check now. Let me go, yeah. So we have created a figure. X we have given as a horsepower, and Y we have given as a acceleration. So these are two different variables, and we have given a label. X label is given horsepower, this is Y label, and this is the title, and this is the grid, and legend will be true. This will be shown, and it will be shown. Let me execute this. So this is the scatter plot this is the bivariate scatter plot for this particular data. And on axis we have horsepower, and Y axis we have acceleration. Now my question is, what is the relation between horsepower and acceleration? So what insights we are getting from this particular graph? You can put your answers in the comment box of this particular video, right? So let me discuss this also. So by observing this chart, right, we can say that horsepower, if it is going to increase, right, then acceleration is going to decrease. If acceleration is going to decrease, right, so it's a positive relations or negative relations? It's a negative relation, and it's not in the complete perfectly straight line or highly straight line, right? Highly negatively correlated. It's a low negative correlated. So this is the way using which we can do the bivariate scatter plot, right? Now let's go for last type, that is multivariate. In multivariate we can have different variations. So let's go the first variation, right? So the same thing we have done, right? We have created a figure. We have used the scatter plot method, and here we have passed the complete data frame, that is DF, which is available. X is our horsepower, Y is our acceleration. So X is horsepower and Y is acceleration. And if you are not going to pass this particular parameter, then this is going to become bivariate analysis. But if you are going to add this hue parameter, right, hue will add the third dimensions, right, and the third dimension will be based on origin. And this hue is going to make the color coding based on the different values present in the origin. In origin, we have three values, right? USA, Japan, and Europe. So randomly, some colors will be given for USA, some color will be given to Japan, some color will be given to Europe, and based on that, these data points will be plotted. So now individually, what we can do, we can check the trend of only USA cars. You can take this, we can find out the trends of only Japan cars. We can find out the trend of specific only cars from Europe. So if you see here, what will be conclusion? The conclusion will be again same, right? By observing this chart, we can say that for USA origin cars, horsepower and acceleration is having low negative correlation. Even for Japan car also, Japan color is basically orange. Orange color is also having negative correlations, and it's again low negative correlations. And for Europe, it's again green dots you can see. In case of green dots, it's a negative correlations, but it's again low negative correlations. For all these three basically are having negative correlation and so on. Now, instead of color coding, right, can we have another way to add third dimensions? Answer is definitely yes. So what we can do, we can go for size. So instead of this hue parameter, we can go for size parameter. So let me show you. So this is the size parameter. So if you specify size here, and we can give the size range. So the maximum size will be 100 and the minimum size will be 10. Then if you're going to execute this, then you can see the USA size will be given as this. This is basically 10 size, and the maximum size is basically given for Europe. That is this big size circle, and in between that Japan will this Japan circle is basically in between this and this. The size of Japan will be in between 100 to 10, and you can see this small circles are basically USA data points. Very big circles are Europe data points, and the middle circles, so this one, again this one, so these are basically circles for Japan cars and so on. So we can go for multivariate scatter plot using this way also. So instead of color coding, we can go for size basis also. Even if you think can we integrate this size base and color coding together, the answer is yes. So size is given plus hue is also given. So hue will add basically color coding. So if you see now, the same thing is done, just only color we have changed. So for USA, small circle, it's in the blue. Japan, medium circle, it's in the orange, and Europe, big circle present in the that is green color. Now there is one more option to add the third dimension, that is so see, by observing these cars again, our insights basically patterns will be same. So USA cars having low negative correlations, Japan cars having low basically negative correlations, and Europe origin cars are having low negative correlations. Even if you go for third way, the third way is basically, can we use different symbols for different origin categories? Answer is definitely yes. So instead of size, we can give a style parameter now. The style equal to origin. These things will be remain same. This is basically a little bit customization. X label, Y label, title, grid, and show. And markers we can specify here. So we have three different categories present in the USA. So for first, it will be shown USA. It will be shown a circle. Star will be shown for Japan, and the square will be shown for Europe. So you can see now different symbols are present. So here is the star, here is the square, and here is the basically circle. So using which we can add third dimension. Definitely we need these two variables also. So horsepower will be x-axis, acceleration will be y-axis, and third axis will be added into the graph using this kind of different symbols. Can we do the color coding? Answer will be yes. So the same code will be used along with hue parameter. So if you are going to use same code along with hue parameter, hue is basically again given to the origin, then this is basically a color coding. For USA, different symbol plus different color. For Japan, different symbol plus different color, and Europe, different symbol for a different color. So you can see this is basically USA data points. This star is basically Japan data points, and this basically Europe is basically a square, that is green color, a square. So the insight will be again same. USA cars having low negative correlation, Japan cars and Europe cars also having no negative correlation. I think this is enough for this video. So if you found this video useful, you can like, share, and subscribe to the channel, and you can share this video with your friends. Thank you.